If you're planning to get into learning Linux, a widely used and versatile operating system, then this course is for you. Here you will learn some basic concepts and commands in Linux. Hi, my name is Osama Abu Omar, and I will be guiding you throughout this course. Linux is a computer operating system, sitting beside the well-known Microsoft Windows and Mac OS. It was initially released by Linus Torvalds in 1991, and it's been under continuous development ever since. Linux is open source, meaning that the actual source code is open to the public for both modification and distribution. Over time, Linux has evolved to be versatile and is used all over the world. It is widely used in a lot of areas such as personal computers, smartphones, servers, embedded systems like smartwatches, televisions, and video game consoles. One thing important to mention here is that Linux is under what is called the GNU General Public License. And what this means simply is that the source code for Linux is available to the public for both modification and distribution, either commercially or non-commercially. This has helped Linux to be wildly successful as it is today. A Linux distribution is an operating system formed by a combination of the Linux kernel and some software and application choices. These are separately maintained by a group of people or organizations. There are many well-known distributions like Debian, Red Hat, Arch, and others. Other distributions are mostly derived from these major distributions. For example, Ubuntu is derived from Debian and CentOS is derived from Red Hat. You can take a look at many available distributions and learn more about them by visiting distrowatch.com. It is most recommended that you use a well-known distribution. The terminal is an environment where you simply use your keyboard to write some text and then you get output on your computer screen. Back in the days, the terminal was an actual physical device that you sit down at and use the keyboard and screen. Well, today we use terminal emulators, a text-only window on your GUI. We use the terminal to do all sorts of things, like working with files, installing packages, managing system users, and many others. The terminal is interactive. You specify commands to run, then the terminal outputs the results of those commands. Executing any command is done by typing it and then pressing enter. The shell is a program that provides the traditional text-only user interface for Linux. We give it command lines and then it processes the commands and returns some output. To summarize, we open the terminal emulator, a black window appears that runs the shell so I can run my commands. We'll be using the bash shell, which is available almost everywhere. The shell allows you to execute many useful commands. If you want to go along with the examples, you can use the terminal on your own computer. If you're using a Mac machine like me, commands in this course will work just fine on your Mac, since Mac OS and Linux have much in common. The terminal app in the Utilities folder in Applications. To open it, either open your Applications folder, then open Utilities and double-click on Terminal. Or you can press Command and Spacebar to launch Spotlight and then type Terminal. Then double-click the search result. On Linux, to quickly open a terminal window at any time, press Ctrl, Alt, and T. A graphical terminal window will pop right up. I will assume that you're using the Debian-based Ubuntu Linux, but the terminal is just as easy to find if you're using a different distribution. On Windows, you need to make sure that Windows Subsystem for Linux is installed. You can install it and enable it only if you have the Windows 10 Anniversary Update. After that, click Start All Apps, then under the letter B, click Bash on Ubuntu for Windows. You can use any virtualization software to install Linux as a virtual machine on top of Windows. An example would be the free VirtualBox, though this is beyond our scope here. You can also use a cloud provider. If you don't want to mess with your own computer, you can use a Linux-based machine from the cloud. A great example would be DigitalOcean.com. You can sign up and get a Linux machine up and running in less than 5 minutes. They even give you a starting $100 credit. I will be using macOS throughout the examples I'm about to show you here. All examples will work exactly the same on Linux and Windows setups. In order to use the commands we'll be talking about, first, you'll need to understand the structure of the command line statement. The command statement has three parts. First, the command, which is the program you will be running. There will be always a command. Then you'll have the options. These are optional and there can be more than one. An option modifies the command, changing the way it performs, telling it what data to use or control the behavior of the command. Most options start with a dash and a single letter. You can combine more than one option by combining the letters. Then you'll have the command arguments. Arguments, also called parameters, indicates on what the command is to perform its action, usually a file or a series of files. Let's take an example. ls-a documents. Ls here stands for list. It will list the files in a given directory. We give it the option -a, which means that it will list the files, also hidden files. And then the arguments, which are the documents folder. So this command here will list all files, including hidden ones, inside the documents folder. The Linux file structure. You need to have an overview of how the Linux file system is structured. If you're a Windows user, you're probably familiar with the C and D drives as a starting point or root folders on your computer. Well, in Linux, there's only one root folder called the root directory, assigned with a /. All files and folders are somewhere in that root directory. There is a standard in the foundation of Linux called the File System Hierarchy Standard, or FHS. This standard defines the structure of file systems on Linux. The File System Hierarchy Standard defines the directory structure and the directory contents in Linux distributions, so that distributions could have a single reference point from which to work. Let's look at some of the main directories. The root directory. Everything on your Linux system is located under the root directory. You can think of the root directory as being similar to the C directory on Windows, but this isn't strictly true, as Linux doesn't have drive letters. While another partition would be located at D on Windows, this other partition would appear in another folder under the root directory on Linux. The home folder contains a home folder for each user. For example, if a username is Bob, you have a home folder located at /home/Bob. This home folder contains the user's data files and user-specific configuration files. Each user only has write access to their own home folder and must obtain elevated permissions to modify others' files on the system. The /root directory is the home directory of the root user. Instead of being located at /home/root, it's located at /root. This is distinct from the /, which is the system's root directory. The configuration files. The /etc directory contains configuration files which can generally be edited by hand using a text editor. Note that the /etc directory contains system-wide configuration files. User-specific configuration files are located in each user's home directory. Now let's talk about Linux users. The great thing about Linux is that it can manage multiple users accessing the computer at the same time, and it is designed to do that very well, and right from the beginning, decades ago. Let's take a simple example. John has a user. Katie also has a user. They both have separate home directories in /home/John and /home/Katie. Neither of them can read or mess with each other's files. You can switch between different users using the su command, which refers to set user or switch user, followed by the name of the user you're switching to. There are mainly two types of users in Linux: a normal user and a super user or root user. Normal users, like John and Katie, can only access their own files in their home directories. Super users generally have more power and have more control over the system. They can access all system files, install or remove software, browse other users' home directories, and start and stop system services and do other things. The root user or super user's home directory is located at /root. Only the super user can access the /root directory. Normal users' home directories are located at /home/the username. You need to understand that root has two different meanings in Linux, and depending on the context of speech, when we're talking about system users, root is the super user with highest privileges, and when talking about file system structure, /root is the home directory of the root user. A group is a collection of users. The reason for having groups is to define a set of privileges for a given file or directory that can be shared among the users within the group. Users can be added to an existing group to get all privileges that this group has. For example, we can set privileges like the following. John can read and write to file X, and all users within the staff group can only read the file without the ability to write to it. This is what groups are mainly made for. Now, let's talk about Linux file permissions and ownership. Every file in Linux has an owner user, an owner group, and custom permissions for the owner user, group, and everyone else on this system. Now, it can be a little difficult to understand at first, especially if you're just starting to use Linux, but it will become trivial once you grasp the concept. Let's take a look at the file permissions string. The first symbol is the type of file. Here dash means it's a file, and D stands for directory. Okay, now user permissions. The first three letters are the set permissions for the owner user. The second three are for the owner group, and the last three are for everyone else, which means all other users on the system who are neither the owner user or belong to the owner group. Now, to understand what the letters mean, R stands for reading permission, which controls who can read the contents of the file. W stands for writing permission, which controls who can modify the file but not read it. X stands for the execution permission, which controls who can execute or run the file. There are other letters, but they're out of our scope in this course. We can use the command chmod to alter the permissions for our files. There are different ways to use the chmod command here. We will be using the symbolic way to do it, as this is the easiest way and sits just right for our beginner course. We can add or remove permissions by using letters. User is represented by the letter U. Groups are represented by the letter G, and others by the letter O. We can refer to all at once by using the letter O. We can also refer to all of them by using the letter A. There are three operators to the command we need to understand. Plus adds the permissions if it's not there. Minus removes the permission. Equals resets the permission to whatever value we specify. There are two commands that can easily change the user and group ownership of a file. Change own user, the file, and change group, group, and the file. Note that you probably won't need to change ownerships and permissions that much, unless later on if you're working with web servers, for example, and need a way to grant some privileges to make things more secure. Now let's talk about the command pwd, shortcut for print working directory. This is one of the most basic commands you can find on Linux, and you will be using this command very often. pwd, when hit enter, it prints the full path of the current working directory. Right now it's /home/sam. Another command you will be using quite often is the ls command, or list. This command simply lists all files and folders inside the current working directory. So if we hit enter, we can find 3 items inside the current working directory. We can also give list a custom path to list all the files and directories inside that path. We have many options to choose from when executing the list command. For example, ls-l, which stands for long version. This command lists the same files but with more details. Another option is the -a command. -a stands for all items. This will include all hidden files. When we give the -a command, we tell Linux to include hidden files. So basically in Linux, any file that has a name starting with a dot here is considered a hidden file. So if you open the File Explorer in your Linux machine, you won't see this file by default. One more option is the -h command. H stands for human readable. If we take a look at the previous command, ls-l, we can see every file here can have a look at all the files and how much space they're taking. So this number here is in kilobytes. The -h command displays this size in a more readable format, like megabytes and gigabytes, for example. As we can see here, the -h option is only usable when used along with the -l option. So let's try it out. ls-lh. As we learned before, we can use 2 or more options just like this here. We're using the same dash. Okay, now we hit enter. If you can see here, now it's displayed in a more human readable format, which is 4 kilobytes. Now let's take a look at the cd command. cd stands for change directory. This command will change the current working directory to the one we're giving it. We can give it an absolute path or a relative one. So if we go back one step and print the current working directory using the pwd command, we can see we're now inside /home/sam folder. Now let's take a look at the contents of this sam folder. Using the ls command, we have a directory, another file, and a file. If you want to change the current working directory to the A directory, using the cd command, we can just type A directory. So now we're inside the A directory. To confirm, we can use the pwd command again, and there you go. We can also give the cd command absolute paths. For example, let's go back one step. cd/home/sam pwd. Now we're back to the original directory. Any path that starts with the slash or the root directory is considered an absolute path. Now let's say we want to create a new folder or a directory. Now that's easy in Linux. We only have to use the make directory command, or mkdir. We only need to give it the name of the directory. So for instance, let's give it another directory. Now let's use the list command. We have another directory. Now, what if we want to delete a file or a directory? To do that, we simply use the rm command, which stands for remove. We can give it the file name. For example, let's see what we have. Okay, let's try to delete file.txt. Here, all we have to do is to type in rm and then the name of the file. Hit enter, list again, and now we see that the file is gone. To remove a directory, we need to specify one option, which is -r, and then the name of the directory. -r means recursive. It will delete the folder and all files and folders within it. Let's try to delete the another directory. Another directory. Hit enter. And as you can see, it says that I cannot remove the another directory folder because it doesn't exist. If you notice, we can see here that we had a typo in the name of the directory here, missing folder, a missing letter. So let's try to remove that. -r, another directory. One tip I want to give you here is that you can use the tab button on your keyboard to make auto-completion work for you. Now, if I hit tab now, you see it auto-completed the name of the directory or file and predicted that from the current working directory. So it stopped, as you can see, it stopped after the underscore here because we already have two names, one a folder and another a file. So if we give it a letter D and then hit tab, it will know that I meant the directory. Now if I hit enter, list again, we notice the directory is gone. Now let's have a look at the cp command, which stands for copy. We simply use this cp command or copy to copy files from one place to another. If we have the list command, let's have a copy of another file .txt here and name it file.txt. cp another file .txt to a copy.txt. ls again. Now we have our copy. We can also copy a directory. So let's copy a directory to another one. cp a directory to copy directory. If you notice here, in order for this to work, copying directories, we have to give cp the -r option. Let's try. cp -r a directory to copy directory. Less again, and now it worked. Now we move on to the move command, mv. We use the move command to move files or folders from one place to another. We can use it in two ways. We can use it to simply rename a file or a directory or to move it to another place. Let's have an example here. We can rename, for example, a copy.txt to file.txt by using the mv command. mv a copy to file.txt. This will move the a copy.txt file to the same exact directory, and thus we'll simply only rename it. If we hit enter, list again, we see that the file is renamed. Now, to use the mv command to move a file, for example, from one place to another, let's have an example. Let's move the another file.txt to the copy directory. So we simply do this, move another file.txt to copy directory. This will move the .txt file to inside this directory. Now let's list again. We see that the file is gone. Let's list the copy directory. We see that the file, another file.txt, is moved. Now let's say we need to edit some text file using Linux. Well, there's a program called Nano. Nano is a simple text editor that is installed by default on many Linux distributions. It is an easy-to-use text editor that is very simple and versatile. We can simply use Nano by typing the Nano program and then whatever file we need to edit. Let's have a quick example. Let's see what we have. Let's try to edit the file.txt file here. So we simply use nano and then the name of the file, file.txt. Remember, I had the tab button to autocomplete here. And then hit enter. You notice we have opened the Nano program. Now at the top, you can see the name of the program, which is Nano, and the version number of Nano, 2.9.3. Here in the middle, you can find the name of the file we're currently editing. And here in the middle, you can see the contents of the file. File.txt is currently an empty file. And down here at the bottom, you can see some shortcuts that makes Nano an easy to use program. For example, we can just hit Control X to exit the program. Let's try to write something here. Hello there. And then to simply save the file, you can hit Exit, Control X. If you notice here, it will know that you haven't saved your changes and will ask you to save your changes or not upon closing the document. So you can answer by typing the following choices. You can have Y to say yes, save my changes, and then N for no. Let's hit Y, and then it will ask you to name the file, or it will give you a default name based on the default original name. We can change that, but we'll stick to it. Then we can hit enter. We just got out of Nano. Nano is closed now. We can all see the file. Let's reopen the file using Nano. You can see that we have our changes. Now, if we hit exit with Control X, it will exit automatically without asking us to save any changes, since we haven't made any. Let's get back to Nano. Down here at the bottom, these are actually called the program functions. We only see some shortcuts right here. These are the most common ones. We can hit Control G to get some help. You can scroll down using your mouse or keyboard, just as normal. You can find many shortcuts here. Control X to close again. Notice how these shortcuts change as you're going into the help. So Control X to exit, get out of help. We can also make some changes here. Control O to write out the changes without having to close the file. Control W to find some text using Nano throughout the whole document, and other shortcuts. Let's add a new line, another line of text. We can use Control O to write out the changes or save them without having to close Nano. So we only have to type Control and O. It asks us to change or to give it a name. We'll only use the default name, which is file.txt, and hit enter. If you see the message here, it says wrote 2 lines. So our changes are saved. We can get out of Nano using Control X, and you noticed it didn't ask for saving changes since they're already saved. Now let's talk about navigation using Nano. You can navigate inside of Nano text using the conventional arrow keys. You can use the left arrow to move the left, right arrow to move right and down, and up arrows to move lines up and down. You can also use the home and page up, page down keys as usual. You'll come to learn that when using tools in Linux, especially in the command line, we usually prefer not moving our fingers away from the letter keys. Like if I want to, for example, hit page down, I have to move my fingers from their position on the keyboard to hit the page down button. In Nano, you're given some shortcuts to avoid that. For example, you can hit Control B and Control F to move backward and forward respectively. Like if I hit Control F, I can move forward. Control M moves one line down, and Control P moves upwards line by line. One tip is you can use Control and Dash and then give it a line number. As you can see here, it asks for the line number, a comma, and then a column number. We can give it, for example, I want to go to line 4. So I hit 4 and column 1, which is the first letter in that line. Hit enter, and there we go. This is especially useful when you're dealing with log files or when you're reading code and you want to go, let's say, to a specific line number in that code. You can use that shortcut. It will be very handy. Now let's do some copying and pasting, just like we do in regular text editors or Word documents, for example. Now, things work differently here in Nano or any other text editor that uses the console. We cannot simply just highlight some piece of text and hit Control C or Command C. This won't work here. We can simply do highlighting using some shortcut commands. Let's say I want to copy this piece of text here. So to start the copying, I must first highlight or mark the piece of text. Now all we need to do is to set the mark using the command plus the exponent or power symbol. We can reach that by hitting Shift plus the number 6. Now let's say I want to, copy this piece of text right here. So I move my cursor to the beginning of the word. So I move. Then I want to set the marker right here. So I hit Control Shift and 6. We see a message that states that the mark has been set. Now we only have to move to the end of the part that we need to copy. Let's say the end of the sentence, right before the period. And then to copy the text, we hit Meta and then the exponent sign. You just hit the Meta key first without holding, and then you hit the exponent key. So here's Meta, I released it, and then Shift plus 6. My text has been copied. Let's say we want to paste it right at the end of the file. To paste it, we simply hit Control plus U, and there we go. Now let's look at searching for text using Nano. We have a shortcut for that. Control W, where is. Now, let's say we want to search, for example, on the Semper word, for example. So we only have to hit Control W. It'll ask us for the search term. Now we'll just hit Semper, and then we hit Enter. Now, as you can see, we can find the cursor has moved from its original position to the first occurrence of the search term. To search for a next occurrence, we repeat the process using Control W. It asks us for another search term and giving us a default search term based on our previous search. We hit Enter to use the default one, and then it sends us to the next occurrence. Control W, Enter, to the third one, Control W, and so on. Now, there's two ways you can start using Nano. You can hit Nano and then give it an already existing file. As you can see, demo.txt, we already have that file. It's already here. We can say Nano and give it demo2.txt. Now, demo2.txt does not exist. And Nano will open a new file, will create a new file named with this name in the current directory. So that's the easiest way to start up a new file. Hit Enter, and then you see we have a new file has been created. Let's write something out, some text, hit Control X, save our changes by hitting yes, Y, and then Enter. Let's list the files again. We see a new file has been created. Let's say that we want to show the contents of a text file, for example, and without you having to use Nano, as we're not going to edit the file, but just view the contents. Well, there's a command called cat. Cat stands for concatenate. Although it has many other uses, cat can be used to spit out the contents of any file directly here to the console. The cat command is one of the most frequently used commands in Linux, and we can use it simply by saying cat and the name of the file. Let's say demo.txt, and here we can see the content of the text file right in the console. We didn't enter nano, we didn't have to edit anything, but just view the contents. One tip, there's another command called clear. It simply is used to clear the console. Clear just simply clears your console. Let's list the files again. Use cat to see the contents of file.txt, and here we go. One of the most common experiences that face newcomers to Linux is the ability to find or search for files and directories. The find command is one of the most powerful tools that Linux provides regarding that issue. You can use the find command to search for files and directories based on their permission, type, date, ownership, size, and more. The command name is find, then we give it some options, and then we give it the starting path. Let's say the starting directory where we want to search for the term, and then our search term. Let's have an example. Let's list our files, list the contents of copy directory. Let's search for the another file.txt file. Find. The starting directory is the current directory. Remember here that dot means the current directory. Using double dot means the parent directory of the current working directory, of course. Let's have a look at that first. So let's list all the files in our system. If you notice here, if we use the -a option in the last command, we will always find these two items here, the dot and the double dot. Dot here means the current directory. Double dot means the parent directory. So let's now use the find command. Find, starting from the current directory, and then -name, and then the search term. So we have to put it inside double quotations, and the name of the file is another file.txt. And we get the file. So the file here exists starting from the current directory inside of the copy directory folder, and then we find the file. So find is a pretty convenient way to look for files in the easiest manner. We can also use the find command to filter out files and not directories. We can use the -type option. So let's find all text files within the current directory. So find within the current directory, and of type, here's the option, type F. F here stands for file. Hit enter, and we get all the files. We can also find files that have the extension of txt, meaning text files. So by combining multiple options, type F, and then -name, filtering by the name of the file, we can use an asterisk. We can use this asterisk symbol as a wildcard to mean anything that ends with .txt. So this symbol here will match up to all characters. Hit enter, and then we find all text files in the current directory. If you ask yourself, when do I find more options to, let's say, the find command? So there has to be a place where I can find some manuals that explains in more detail all of the commands that are supported by Linux. Well, you can use the man command, stands for manual, and then the name of the command, let's say find, hit enter. You will find the detailed manual stating everything about the find command. You can scroll down using the arrow keys, And if you're done reading, you can hit Q to quit the manual and return back to the console. Let's see the manual for the ls command. You can see the name of the command and how to use it and all the options that are supported. Hit Q to quit. The Linux manuals are a fast and convenient way to look up for some options and more details about a specific command right from your console. Let's go back to the ls command. We can use the ls-l, the long version command, to see all file permissions and ownership information. If I type ls-l, in the long output of ls, there's two columns that show the user and group ownership of each file. The owner user of this file, demo1, is Sam, and the owner group is staff group. You can see the file permissions of demo1.txt here. The first symbol here denotes the type of file we're looking at. A dash means that this is a regular file, and a character D means that this is a directory. There are other types of files, but this is all we need to know right now. Here we can find the permissions for the user, the permissions for the group, and the permissions for other users. So the owner user can read and write to this file, so as the owner group, but other users are only allowed to read the file without making any modifications. If you notice down here in the script.sh file, it's a regular file. The owner user, which is Sam, has the permissions to read, write, and execute the file. Notice that it's colored green, meaning that it's executable by the current logged in user, which is Sam, the owner user. We can change the set permissions for any given file using the command chmod. Let's say, for example, we need to remove the write permissions for the group owner of the demo1.txt file. We don't want staff to be able to write to the file. So to do that, we write chmod and using the symbolic way to alter the permissions. So we say G means group minus the write permissions and the name of the file. The command is executed. Now let's list the files again, and we see that the write permissions are gone. We can also change the owner user and owner group. There's a command for that called chown, change the owner. Now let's say we want to change the ownership of demo1.txt to another user. We have a user on the system called John, so let's give him ownership. chown John and the name of the file, demo1.txt. And we see that John is now the owner. Notice that I am currently logged in using the root user. You have to know that when using the chown command, and especially to change ownership of any file, you need to have super user privileges or to be the root user on the system. You only have to run this command as a super user or the root user if you change the owner or the group to a group you don't belong to. You don't need the super user privileges to change the group to a group you already belong to. We can also change the group owner of any file using the chgroup command. So in the same way, we state the new group. Let's say we want to change the demo to owner group ownership to the sales group. So we only state sales and the name of the file. We can also use the same chown command to set the owner user and group at the same time. To do that, we say chown, the name of the user, John, for example, and a column, and then the name of the group, and then the file name.